Now, coming to the properties of alkenes, I already said you, alkenes undergoes substitution reaction. Alright, it undergoes substitution reaction because it comes under saturated hydrocarbons. Alkenes, it undergoes. Alright, so we are going to see the substitution reactions now, one by one. So, first of all, we will come to halogenation. The one which I am going to say is halogenation. Halogenation means reaction with any halogens. Either we can take chlorine, bromine or iodine, we can say that. But not fluorine. The reason is that with fluorine, the reaction is highly explosive because when fluorine-fluorine bond ruptures, means it breaks, a huge amount of energy is liberated. Or a huge amount of. So hence, for that particular purpose, what you find is that later on you will study in higher classes that fluorination, never we do it for that particular reason. Directly we never do, indirectly we do it. What is that? How it is, you will learn in higher classes. But now this much I can say you that we don't go for fluorination, we rather go for chlorination, for bromination and iodination. Alright, clear? Chlorination, bromination, iodination, we go it. Clear? But in iodination also there is some clauses is there. Let me tell you later on. First let me tell you chlorination. Alright, now understood why this fluorination is not being done? Because whenever any compound reacts with fluorine, the reaction is highly explosive. Because when fluorine-fluorine bond, it breaks, it ruptures. The cleavage which takes place. Alright, the breaking up of bond, it takes place. A huge amount of energy, what you can say is that, is being released. We can say that. Clear? For that particular purpose, that is, reaction is highly explosive. Fine. Let me come to, that is halogenation, that is chlorination. Now when CH4 reacts with Cl2 in presence of UV light, UV light means ultraviolet light, or you can say diffused sunlight, that also we can say that. Alright, diffused sunlight means the sunlight which is coming from the doors, windows or ventilators, that is said to be as diffused sunlight or indirect light, we can say that. Clear? So what you will be getting in? So one hydrogen will be replaced by chlorine because I said substitution. Alright, I have explained you last class. What is substitution? One hydrogen will be replaced by chlorine, CH3Cl plus HCl it is going to form. That is methyl chloride it is known as, or chloromethane, monochloromethane, because one single chlorine is there. Now you see, it's a stepwise reaction. CH3Cl plus Cl2, again in presence of UV light or diffuse sunlight or slightly heating also we can do it. Alright, that also is being done. So what you will get? Another hydrogen will be replaced. Another hydrogen will be replaced by another chlorine. So what you will find is there that hydrogen is decreasing and chlorine is increasing. So what is the name of this compound? It is called as methylene chloride. Methylene or dichloromethane. Dichloro, one carbon is there. Meth, it is methane, single bond. Now next is CH2Cl2 plus again Cl2. What you will get? You will get CHCl3 plus HCl. CHCl3 is what? Chloroform. It is known as chloroform. Correct? Or we can say trichloromethane. IUPAC name is very easy. These are the common names I am saying you. Methyl chloride, methylene chloride, chloroform, they are the common names. And IUPAC name is monochloromethane, dichloromethane, trichloromethane. So easy it is. Okay, fine. Now next is CHCl3 plus Cl2. It is what? CCl4 plus HCl. What is the common name? Carbon tetrachloride. Carbon tetrachloride. Or we can say tetrachloromethane, one carbon. Alright, tetrachloromethane. So methane does not mean it should have CH4. Methane means it should have one carbon, meth and single bond. Yes, CCl4. What is the structure of CCl4? This is the structure. All are single bond, you know that. So this tetrachloromethane. Try to understand this. Methane does not mean that CH4 will be there, then chlorine will be there. Then how? How it is possible? Carbon will have more than 4 bonds, which is not possible. Understood? So you need to understand this. So this is, I have done it for methane. I have done the halogenation reaction, you can say. If you take an ethane, then you will be getting 6 steps. Why? Because 6 hydrogen atoms are there. So in each step, every hydrogen atom is replaced by chlorine. Alright, here 4 hydrogens, so 4 steps I have done it. If I take ethane, it is 6 steps the reaction will be done. It will be carried out. Alright, but the same thing it is will be done. You will be getting it. In every step, one hydrogen will be replaced by one chlorine. Alright, in every step. So there you will be getting monochloroethane, dichloroethane, trichloroethane, tetrachloroethane, pentachloroethane and hexachloroethane. You will be getting it correspondingly. Now, If you do the reaction with bromine, let me come to bromine now. Same thing, just instead of Cl2 we'll be using Br2. Now instead of saying CCl4, I will say CBr4. Ultimately, in all cases Br will be there and I will be saying CBr4. So what is the name? Tetrabromomethane, and here you will be getting HBr. Use the common sense. Alright, instead of Cl2, if it is Br2. Alright, instead of Cl2. Why I am saying? Because all the steps will be the same. CH4 plus Br2 will be CH3Br plus HBr. In this way you will come to the last step. In the last step also same thing. You will be using your CHBr3 plus Br2. You will be getting CBr4 plus HBr. So tetrabromomethane. Alright. Same thing with iodine. But in iodine you need to understand one more thing. See here. Here that is CH4 plus I2. Same thing. You will be using UV light. You will be getting what is that? That is CH3I plus HI. Now this reaction is reversible. This reaction is reversible in nature. Why? The reason is, listen carefully. HI here which is formed is a strong reducing agent. Always remember all halogen acids, whether it is HCl, HBr, HI, HF, all are what you can say reducing agents. All are reducing agent. HF, HCl, HBr, HI, all are reducing agent. Alright? But the strongest reducing agent is, in case of halogen acids, is HI. Why? Because the bond between hydrogen and iodine is the biggest. The bond between hydrogen and iodine. Why? Iodine is a bigger atom compared to bromine, compared to chlorine, compared to fluorine. So HF is the strongest bond. Because fluorine is smaller, H is smaller, so bond is also smaller. Again, chlorine is bigger than fluorine, so bond is slightly bigger between H and Cl. Again, you come to bromine. You know the bromine atom is bigger than the chlorine atom, because down the group atomic size increases. So bromine is slightly bigger than what you can say chlorine. So again, HBr is slightly bigger. The bond length between H and Br is slightly greater than that of HCl. Now H and iodine is a bigger atom. So there is a maximum bond length, and I've said you always that the bigger is the bond length, weaker is the bond. Like this particular pen, you can see I can break easily, but if I take the cap, can I break it easily? No. If I take this cap, it is not easy to break. So you can imagine this is the bond length between H and F, and now this is the bond length between H and I. Which is easy to break? Definitely this bond is easy to break compared to this bond. We can say that this bond. Clear? So in this way, for that particular reason, this is the bond length between H and F. Just an example I am giving you, and this is the bond length between H and I. So this bond is a weaker bond, because bigger is the bond, weaker is the bond. Smaller is the bond, stronger is the bond, stable is the bond. So hence HI is a very strong reducing agent. Why I am saying you? Because when HI, the cleavage will take place here. What happens? Hydrogen is released, and that hydrogen helps in reduction. Hence HI is used as a strong reducing agent. We can say that. Clear? So HI is a very strong reducing agent. So it makes the reaction reversible. That means it reacts with CH3I to form again CH4 and I2. To form again CH4 and I2. Then how will you prevent it? How will you make the reaction irreversible? Alright, it is reversible now, because HI is a very strong reducing agent. Alright, here you may ask, HCl does not. No, what I said you, HCl is a reducing agent, but not as strong as HI. For that reason, it does not make the reaction reversible. Remember it. It does not make the reaction reversible. Fine. Now, if I want to make the reaction irreversible, what I need to do? That is here. This is, I want to make the reaction in the forward direction only. Hence, I have to use an oxidizing agent, which is known as red phosphorus. I will be heating at a temperature of around 420 Kelvin. Red phosphorus. What red phosphorus will do? It will react with HI to form Pi3. Alright? And hydrogen will react with oxygen to form water. In this way, what I said, red phosphorus acts as an oxidizing agent. Oxidizing agent. It oxidizes HI. And hence, HI does not get a chance to further react with CH3I to form CH4 and I2. I think you got it, this particular thing. So that is the thing you have to remember. So whenever you write the reaction with CH4 plus I2, you need to write this particular condition. Then only the reaction becomes irreversible. If you don't write this, the reaction is reversible. Not possible. So I hope you understood this particular thing. So this is your halogenation reaction, so to say. halogenation reaction, or I should say chlorination, bromination and iodination. I've explained you. Fine. Now next is, after that we'll come to oxidation reaction. Now remember it always that any hydrocarbon burns in air to give always two products, carbon dioxide and water. Any hydrocarbon, whether it is methane, ethane, ethene, ethyne, ethanol, acetic acid, aldehyde, ketones, any hydrocarbon, it burns in air, it oxidizes, it undergoes combustion in air, got it, in oxygen, sufficient supply of oxygen to form carbon dioxide and water. You can say that CO2 and H2O. Clear? So in this way it burns here. So you'll balance it this one. So how many oxygen here? There is 2 O2, 3, and hydrogen it is 2. Done. In this way. So you can see that the reaction is taking place in this way. Now if you take little bit less oxygen, got it? That is if you're taking limited supply of oxygen, what do you get? Very simple. Instead of carbon dioxide, you'll get carbon monoxide and water. You'll be getting, clear? You'll be getting nothing but carbon monoxide and water. So what you will do is here, that is nothing but to balance it, this is here oxygen is 2, oxygen 2 we got it. Now hydrogen is, what you can say, here it is 4 hydrogen. So if I put it here 4, so I get it here, okay fine, let me do it. So now this oxygen is 3. So here it is, if I put 2 here, 2CH4 here, the 2 4s are 8, so 8 hydrogen it becomes, my goodness. So 2 carbon, so carbon monoxide, we can say that, and 2CH4, and here it is how many oxygen we got it? 4 oxygen. So 4 oxygen means 2O2. So oxygen here it is 4, oxygen here it is 4, here carbon is 2, here carbon is 2, balanced. Hydrogen is 8, here hydrogen is 4, I am getting it, isn't it? So what I need to do is that, that is here I will, if I make it as 4, then oxygen becomes 4 to just 6, that means it is 3O2, correct? Now let me see, 2 carbon, 8 hydrogen, now oxygen 6, done, yes. So this is the reaction. So here it is, what you can say is that limited supply of oxygen I have taken it, limited supply of oxygen. Now don't compare it, say here 2 and here 3, how it is limited. See here 1 mole, here 2 moles, that also you see it. Here the ratio is 1:2, here the ratio is 2:3, alright, that also you see. Now if I take very limited supply, if I take, that is, so what I am going to get it, if I take very limited supply, I am going to get it, very limited means this, or in insufficient oxygen, if I heat it, what I will get? Carbon and that is nothing but hydrogen. Generally what you find is that this particular reaction, it is also called as pyrolysis. Alright, it is also called pyrolysis or cracking. Now listen carefully, write it down. What is pyrolysis or cracking? Heating of alkenes in absence of air or in limited supply of air, very limited supply of air, to form the corresponding alkenes or alkynes is known as pyrolysis. We can say that. What I said? Pyrolysis or cracking, I should say that. Again I repeat, heating of the alkanes in absence of air or very limited supply of air to form the corresponding alkenes or alkynes is known as pyrolysis or cracking. Now you might be wondering where it is alkenes or alkynes. Yes, I have taken here one only, 1 methane, 1 mole of methane. So I got C plus, what is that? To balance it, I'll put it here 2. Fine. If I take 2CH4, 2 moles, then what I'll get it here? I'll be getting here nothing but HC triple bond CH plus hydrogen. Alright, I'll be getting here, that is HC triple bond CH plus hydrogen, that is ethyne, I got it, clear? So 2CH4, now here 2 carbon done, here 8 hydrogen, here 2 hydrogen, so here it is 3H2. Alright, clear? If I take here, that is, let me write here, C2H6 if I take, and if I hit it in absence of air, see, no oxygen is there, no oxygen, in absence of air or limited supply of air, limited means hardly something, and that will not influence the rate of the reaction, we can say that, clear? So here it is. What I am going to get it? I am going to get C2H4 plus H2. That is ethene. You can write in this way also. Instead of C2H4, I always suggest you to write in this way. H2C double bond CH2. The structure. That is ethene plus hydrogen. So methane on heating at a temperature of. Now you might be wondering how much the temperature I should take. The temperature you should take it here is around 1500 degrees Celsius. And here the temperature you should take it around is 1000 degrees Celsius. We can say that. Clear? So when you will be heating at a very high temperature, what I am going to get it? I am going to get this corresponding alkenes or alkynes. Now, if you want to reduce the temperature here, suppose you will say, no, I will not take 1000 degree. You can take 500 also, no problem. You can take 500 also, but you need to take a catalyst then. Catalyst. That is in presence of Al2O3 acts as a catalyst. You know that very well. That if you want to reduce the temperature, or if you want to take lower temperature, then you need to take a catalyst, because catalyst will alter the rate of the reaction. Here it is going to increase the rate of the reaction. Understood? That also is possible. Lot of things are there to be learned here. Lot of things. So hence understand it properly, each and every point. So in this way, this is known as your pyrolysis or cracking, and these are the oxidation reaction. In what you can say, sufficient supply of oxygen, you get carbon dioxide. In limited supply, you got carbon monoxide, and in very limited supply, you get carbon and hydrogen, and or you will be getting this pyrolysis reaction or cracking reaction, so to say. Clear now? Now next is some more oxidation reactions are there. Some more oxidation reactions are there. We will come to it. Like suppose if methane is heated in presence of copper tube, methane, CH4 is heated in presence of, heated in what? Air. In presence of copper tube. Copper tube is your nothing but catalyst. Alright, around 200 degrees centigrade. Let us say you are heating it around 200 centigrade. What I am going to get? That is alcohol, methanol, we can say that. CH3OH, you will be getting it. Suppose if you take here ethane, C2H6 plus O2, same thing, copper tube at 200 centigrade, you will be getting what? Ethanol, C2H5OH. Alright? If you take ethane and oxygen, same condition, you will get ethanol. If you take propane and oxygen, same condition, you will get propanol. That means here this particular, what you can say, substance converts alkanes to alcohol. Now always remember that when alkanes undergoes oxidation, this is a general formula I am saying you, remember it forever. Alkanes undergoes oxidation, this is nascent oxygen. First step, it forms alcohol. First step. Here the reaction is going to complete in first step only. Now if the reaction continues further, if it continues, then alcohol further oxidizes to give you what? That is nothing but aldehyde. It further oxidizes to give you aldehyde. Aldehyde further oxidizes to give you carboxylic acid. You get carboxylic acid in this way. This is the chain reaction, we will get it. Alkanes will give you alcohol, alcohol will give you aldehyde, aldehyde will give you carboxylic acid. So hence, here the reaction stops in one step only. So methane and oxidation will give you methanol. If you take ethane and oxidation, you will get ethanol. Under this condition, the reaction stops in one step. But if you take some other conditions, other means, let us see. For example, here, if I take an oxidizing agent like potassium dichromate acidified or alkaline KMnO4, potassium permanganate. Listen carefully, children. Acidified potassium dichromate. Acidified means K2Cr2O7 / H plus. H plus means acidified. Alkaline KMnO4 means KMnO4 / OH minus. That is said to be alkaline KMnO4. Alright, these are very strong oxidizing agent. Very strong oxidizing agent. It will oxidize it further, the reaction. Alright, means if you take here CH4 in presence of nascent oxygen, which will give nascent oxygen? K2Cr2O7 / H plus. This will give nascent oxygen. What I am going to get it? What I said? Alcohol. I said no? Methane alkanes will give you alcohol. Now, next, this is a chain reaction. Here secondary product is not important, so no need to write the secondary product. You may or you may not. If you want, you can write the secondary product means water will be formed. No, that is not required. So now next another step, same what you can say chain reaction. No? Same methyl alcohol in presence of nascent oxygen. From where you will get same thing, K2Cr2O7 / H plus. Alright, what I am going to get? Formaldehyde, HCHO. Why one carbon? Because here one carbon I have started. So hence methane, methanol, and this is methanol, IPC name. Or methane, methyl alcohol, formaldehyde, the common name it is. Now again, formaldehyde on oxidation will give you formic acid. Same thing if you start with ethane. Got it? Ethene, same condition, K2Cr2O7/H plus. What I am going to get it? I will be getting ethanol, C2H5H, which on further oxidation will give you CH3CHO, ethanol. That is ethanol, we can say that. Or acetaldehyde, the common name is. And this on further oxidation will give you CH3COOH. That is your acetic acid or vinegar, we can say that. So this is the chain reaction you will be getting it. Here secondary product is not important. Now this reaction is very, very important. In your exams it will be coming. Convert ethane to ethanol. So you have to write 2 steps. Convert ethane to ethanoic acid. All the 3 steps. So it depends what the question comes. But it's very, very important. You have to remember it. Alright, clear? Now next, one more is there. Reaction. So next condition is, what will I do? I will take methane and I will be, that is heating in presence of molybdenum oxide, CH4 plus O2 in presence of molybdenum oxide. Now in presence of copper, when I have heated it, got it? When I have heated in presence of copper tube at 200 centigrade, we got what? Alcohol. Methane gives methyl alcohol, ethane gives ethyl alcohol, propane gives propyl alcohol. Here, methane, first it forms alcohol, no doubt. Alcohol further oxidizes because molybdenum oxide is a stronger oxidizing agent than copper tube. Listen carefully. So what I am going to get it? Methanol plus water. The temperature here is 350 to 500 degrees Celsius. I will be getting, that is nothing but methanol plus water I will be getting it, or formaldehyde plus water I will be getting it. Alright, similarly, if I take here ethane C2H6 plus O2 under same conditions, what will I get? 2 carbons na, CH3CHO plus water. I said you that how to find it out. Here HCHO, you add CH2 group, you will be getting the next. Because here CH4 I have added CH2 group, I got C2H6. CH4 I added CH2 group, I got C2H6. Similarly HCHO, if I add CH2 group, I will get CH3CHO. Alright. So in this way, these are the different reactions which of what you can say of alkanes. And what is the use of alkanes? It is used to prepare chloroformycin. It is used to prepare carbon black, which is used for shoe polish, nail polish and all those things. It is used to prepare formaldehyde, see here, acetaldehyde, formaldehyde, ethanol, it is used to prepare. But it is used also as domestic fuel, methane, natural gas, it is used as domestic fuel. So these are the some of the uses of alkanes. Thank you.